Today, we are going to analyze the application and transport layers. First, open the package tracer. Now open the pt2b file. We are going to do the task 1, repair and test the topology. Firstly, click on the Eagle server, turn on the server, then click the desktop, click the IP configuration, set the IP address to 192.168.254.254. Then the subnet mask will appear automatically. Then set the default gateway to 192.168.254.253. Now, go to the configurations. Click on the DNS, enable the DNS, then set the name as eagle-server.example.com. Then set the address as 192.168.254.254. Then click the add button, then save. Then click on the HTTP, then enable the HTTP. So now we are going to connect the Eagle server to the R1SP router. Click on the connection. We choose the copper crossover. Then click on the Eagle server. Choose fast Ethernet. Then click on the R1ISP router. Choose fast Ethernet 00. Now we are going to configure the PC1A. Click on the PC1A, go to the desktop, IP configurations, and then set the IP address to 172.16.1.1. Then the subnet mask will appear. Then set the default gateway to 172.16.255.254. Then set the DNS server to 192.168.254.254. Then now we are going to connect the PC1A to the S1 central switch. We choose the copper straight through, click on the PC1A, choose fast Ethernet, then click on the S1 central switch, choose fast Internet 01. Then to verify your word, click on the check result. Then it will show that congratulations on completing this activity. Or you can click on the assessment item. It shows that all the assessment items have been done. So now we are going to test the connectivity between the PC1A and the Eagle server. Click on the Add Simple PDU, then click on the PC1A, then click on the Eagle server. So, note that when you add a simple PDU, it appears in the PDU list window as part of scenario 0. The first time you issue this one should ping message, it will show as failed. Now you have to double click the fire button, then it will show successful. Then we have done the task 1. Now we are going to do the task 2. Explore how DNS, UDP, HTTP, and TCP work together. Now shift from the real time to the simulation mode. Then we have to make sure that the event filter is set to display the DNS, HTTP, TCP, and UDP. Now click on the PC1A, go to the web browser. In the URL box, type eagle-server.example.com. Click the Go button. Then use the capture or forward button to capture the interaction of DNS, UDP, HTTP, and TCP. So, to examine the package, you can either click on the package envelope as it is displayed in the animations, or you can click on the info columns. For example, you can click on TCP, then it will show all SI models, inbound PDU detail. You can see the source port, destination port, and other details. Then the outbound PDU detail is show the source port, destination port also, and other details. Now you can click also the DNS. It show OSI models, inbound PDU detail, the source port, destination port, and other details. Outbound PDU detail, source port and destination port, and also other details. Lastly, click on the HTTP. You can see the OSI models and the outbound PDU detail. It shows the source port, destination port, and other details. So now let's make some reflections. This diagram shows the sequence of protocol events involved in requesting a web page using a URL. The client sends the request to the DNS server. The DNS server responds by sending the IP to the client. This is a three-way handshaking. The client sends the SYN bit to the server, and the server sends the SCK and SYN bit to the client. The client responds by sending the SCK to the server as well as the request file. Then the server responds the HTTP OK to the client. The client sends the finished bit to the server, and the server sends back the finished and the acknowledged bits to the client. The client sends the acknowledged bit again to the server. Next, DNS is using UDP to send information with client. UDP is unreliable, so if the packet loss happens in the connection between clients and DNS server, the error will occur. Here is an example. When client requests DNS to the DNS server, packet lost in the middle. DNS did not get the request, so it will respond to the request. Therefore, the client needs to send again the request to get IP. The next example, the client requests DNS to the DNS server. The DNS server receives the request and responds the IP to the client. However, the packet lost in the middle. So the client did not receive the IP response from DNS server. Therefore, the client needs to send again the request to get it. So we have done both the tasks. Thank you for watching.